Hey guys, welcome to lesson 714, day 1. Last week we focused on the sine function, and so this week we are going to put a lot of focus on the cosine function. So if you remember how we were using the screamer ride to kind of understand what was going on with sine, we're going to kind of be still imagining it when we talk about cosine. So when we did sine, we were trying to calculate the height of a rider of that ride at any given position. So as they move around the wheel, how far are they from the ground? Now, instead of that, we want to calculate the horizontal distance from the center at any given position. So like if I was right here, how far away am I from this center axis? It's always going to be about the distance from the center axis with cosine. So let's take a look at how this is going to work. If I am looking for the horizontal distance of a rider at 15 degrees. So 15 degrees, let's say that it's about here somewhere. And I can go ahead and draw my triangle exactly how I drew it when I was working with sine. Same triangle. All right. And I will also draw my little prototype here as I usually do. All right. So now there's a couple of things we know about this triangle that we can label. For example, we know the hypotenuse is 1. That hasn't changed. We know that this angle is 15 because it's in the first quadrant. We don't need to do anything fancy. And we also know what we're looking for, right? Before we were trying to find this vertical height and we called it y, right? Now we're trying to find the horizontal distance. All right, this one, and instead of focusing on that line, we're just going to use the base of this triangle instead, because it would be the same exact length as a line that we would draw here. So we're going to look for the base of this triangle, and we're going to go ahead and call that x. All right, so now we can go ahead and use our SOHCAHTOA. We can say that this 1 is the hypotenuse. The x, that's right next to the angle, which means we can label it adjacent. And because it's a and h, if you recall from when we wrote SOHCAHTOA down, we can see that we have to use cosine, because cosine is the one dealing with a and h. And that's always going to be the case when we're trying to find a horizontal distance, right? We're always going to be working with this side, which is why it's always going to be cosine. So because the hypotenuse is 1, all we need to do here is just take the cosine of 15, and we can use our calculator for that. So cosine of 15, and that gives us an answer of 0.966, we can say. All right, and so we know that the horizontal distance of the rider from the center axis is about 0.966 feet, if this ride had a radius of 1. All right, so we can go to our table and go ahead and, oh, forgot to erase those. Not restarting the video now. 0.966. All right, and if you guys kind of have a vague memory of when we were finding reference angles inside of triangles, we don't have to worry about any of that fancy stuff in the first quadrant. As long as our triangle is here, whatever our angle of rotation is, our position, that will be the angle inside the triangle. So for all of these, the reference angle will be the same as the angle from the car 1. All right, but once you get past that, then the reference angle starts to change. That's where you have to start doing that fancy subtraction stuff. All right, so on to the next one. Let's go ahead and erase this old work. All right, so now we want to know the horizontal distance of a rider at 135 degrees. Now, of course, I should have done this in the very beginning, but it's good to always label your unit circle. I said this last week, and I'm going to continue to say it. These 5 points, you should always start by labeling. It's way easier to work from there. All right, so 135 is obviously right in between 90 and 180, so I'm going to go ahead and put my point right about here. All right, so now I can just go ahead and draw my triangle. Just like we did them before, nothing changes about the way we draw the triangle. All right, so now let's think about what we know about this triangle. We know the hypotenuse is 1 still. So we'll put a 1 there. And we know we're looking for this base x. We're always looking for the base with horizontal distance. Now here's the thing. We know that this angle of rotation is 135 degrees. We know that this part right here is 180. So we need to figure out what this inside angle is. All right, so hopefully you guys remember from last week that you got to do a little subtraction. It's kind of a little game. If this angle is kind of the space between 180 and 135, it'll help us to do 180 minus 135, and that gives us 45. So that tells me that this angle right here is 45 degrees. Okay, so now in order to find the horizontal distance, all I have to do is take the sine of 45. So let's put that in our, sorry, I totally wrote sine when it's clearly supposed to be cosine. Oh, geez. All right. So cosine of 45 is 0.707. So at this position on the ride, this distance right here from the center axis is 0.707. And again, we just use the base of the triangle because it's easier for us. But of course, that and this are the same because you could make like a rectangle or a square here. All right, so this is the distance. However, recall that with sine, anything below ground on your circle was going to have a negative height, right? Because it was going in the negative direction. Similarly, and it kind of works like how a graph works, right? Underground is always the negative y values. Just like that for cosine, if you're on the left side, that's where the x values are negative, right? And you can think of cosine as x values since it's horizontal. So if you're on the left side of the circle, your cosine has to be negative. Okay, left side. So really, this is going to be the correct one. All right, and of course I want to show you guys that yes, this is cool. We did all this work and we found out that the cosine or the horizontal distance is negative 0.07, but just so you know, you could also just do cosine of 135, and sure enough, your calculator knows that it's on the left, and it will tell you, it will give you the correct answer with the negative sign. So you might be wondering, why do we even bother with all this reference angle stuff if we could just type it in as is? And the reason for that is just because I really want you guys to understand the relationship between these base angles and reference angles and just, you know, finding it as is. Okay, but this is the fast way. Alrighty, so let's do 240. Okay, so at 240, and actually let me go ahead and erase all this old stuff. Pause recording. Alrighty, so 240, if you look at your unit circle, which is already labeled for us, 240 would fall nicely in between the 180 and 270. So I will go ahead and put that right about here. All right, this comes at about 240, that's kind of fat. All right, this is our 240 degree rotation. We can draw our triangle. Like that. All right, remember, the triangles are drawn the same way. All right, so let's draw our little mini one. Okay, so what do we know about this triangle? We know the hypotenuse is 1. We know that we're trying to find the base, so we put x right over here. And we don't know this angle inside of the triangle. All right, but we can find it. We know that this angle represents the space between 180 and 240. So if we just do 240 minus 180, that would get us our answer. So that means this is a 60-degree angle. Okay, so I know that right here I can put a little 60. So that tells me, okay, well, let's do the cosine of 60. The cosine of 60, according to our calculator, is 0.5. But, of course, it's on the left side, so it's going to be negative. All right. But again, you could also have just done cosine of 240. I want you guys to understand both. All right, 300. I'm going to go ahead and erase my other stuff real quick. Alrighty, 300 is going to be between 270 and 360. I'll call it right about here. All right, so same process. Draw our triangle. Oops, wrong color. All right, so same exact stuff. We know that this whole angle is 300, that whole angle of rotation. So we use that to help us find the inside here. Because this is 300 and this is 360 and this angle is between the two, we can just subtract them. Oops. 360 minus 300, and that gives us a 60-degree angle here. And then we know that we're trying to find this x value right there, the base. So this is going to be ugly because I'm not using my line tool, but it's fine. Okay, no, I don't like that. All right. So we know here we're dealing with a 60-degree angle. We're trying to find x. Hypotenuse is 1. Label that right here. All right, so now let's find the cosine of 60. That means, 300 has the same cosine of 60. Now, this one was also cosine of 60, so we don't even need our calculator to know that it's going to be 0.5. It stays positive this time because it's on the right side of the circle, right? So this time if we did do the cosine of 300, we would also get 0.5 as well. Right, so let's see, let's prove it. Cosine of 300, sure enough, it is a positive 0.5, just like the cosine of 60. All right, we're almost done here. These two are relatively simple now. So at 180, and of course, let me erase. Alrighty, at 180, you look over here and you're like, okay, well, the 180 is literally just straight horizontal line from the center, right? So if you recall last week when we took the sine of 90 or 270, it was just these ones were where they were also straight radius across, right? But just for sine, it was vertical. This vertical height at 90 degrees was just 1 because it was just one radius length, and we know that our radius is 1. Similarly, when we're doing cosine or horizontal distance, if this is just one radius length away, that means it's just going to be 1. Right, this whole segment is 1. However, because it's on the left side, we have to call it negative. All right, similarly, on this side, the distance horizontally would be positive 1. It's positive this time because it's on the right. All right, so here we know that the cosine of 180 is negative 1. Okay, at 90, on the other hand, well, we know that cosine is asking for horizontal distance from the middle, literally the axis itself. So at 90, we didn't even move left or right. So it literally has a cosine of 0 because it's not even anything away from the middle. It is the middle. So same for 270, right? So we know that the cosine of 90 ends up being 0 because the distance from the center is literally nothing. Okay, and that is all for today.